Greetings and welcome to Talk a Little, Learn a Lot, the American Society of Naval Engineers podcast. I am your host, Stephen Phillips. In this podcast, we talk a little and learn a lot about naval engineering while inspiring the next generation of STEM professionals. Today, I'm joined by the Honorable Sean Stackley, former Acting Secretary of the Navy, to discuss the Aegis Combat Weapons System as part of our special edition of the Naval Engineers Journal, Story of Aegis 15 Years Later, which is a reflection on this important naval engineering feat. Mr. Sean Stackley became Acting Secretary of the Navy on 20 January 2017. He previously served as Assistant Secretary of the Navy, Research, Development, and Acquisition following his confirmation by the Senate in July 2008. Prior to his appointment to ASN RDA, Mr. Stackley served as a professional staff member of the Senate Armed Services Committee. During his tenure with the committee, he was responsible for overseeing Navy and Marine Corps programs, U.S. Transportation Command matters, and related policy for the Sea Power Committee. He also advised on Navy and Marine Corps operations and maintenance, science and technology, and acquisition policy. Mr. Stackley began his career as a Navy surface warfare officer, serving in engineering and combat systems assignments aboard USS John Young. Upon completing his warfare qualifications, he was designated as an engineering duty officer and served in a series of industrial, fleet, program office, and headquarters assignments in ship design and construction, maintenance, logistics, and acquisition policy. From 2001 to 2005, Mr. Stackley served as the Navy's LPD-17 program manager, with responsibility for all aspects of procurement for this major ship program. Having served earlier in his career as a production officer for the USS Arleigh Burke and project naval architect overseeing structural design for the Canadian patrol frigate HMCS Halifax, he had the unique experience of having performed a principal role in the design, construction, test, and delivery of 3 first-of-class warships. Mr. Stackley was commissioned and graduated with distinction from the United States Naval Academy in 1979 with a Bachelor of Science in Mechanical Engineering. He holds the degrees of Ocean Engineer and Master of Science Mechanical Engineering from the Massachusetts Institute of Technology. Mr. Stackley earned certification as a professional engineer in the Commonwealth of Virginia in 1994. Mr. Secretary, thank you for joining me on the podcast. I look forward to our discussion.
It's my pleasure, Steve. This is one of my favorite topics. So now let's dive into it.
Sir, you once said that our missile defense mission began 80 years ago with the V-1 rocket's attacks on Britain. How did that early history shape the founding principles behind Aegis?
Yeah, actually, there was a twofold thing that happened during World War II that U.S. and our allies were just defenseless against when they were unveiled by, in one case, Germany, in the other case, the Imperial Navy. One is the V-1 rocket. Here you have a very rudimentary ballistic missile, not particularly well guided, but something that the Allies had no defense against, and terrorized England. Equal damage, in fact, more damage to civilian infrastructure than a military threat of any sort. But the defense against that threat was equally rudimentary. And so, there was physical barriers that England tried to put up, use of aircraft to intercept things of this nature. Eventually, the V-1 was dulled in terms of its impact, but then along came the V-2. And, the V-2, again, posed such a threat that England was, fortunately, it was towards the end of the war, and its impact was minimized by that. But England was bare open to it. Entirely separately, in the Pacific, you had the kamikaze. And again, here's something that nobody ever envisioned. This is long before a missile threat, but the kamikaze was effectively a manned missile. And the damage that the kamikaze did to our fleet in the Pacific is well documented. And at war's end, we still did not have a good defense against that threat, which over time would evolve from manned aircraft to solid rocket motor missiles. And those two threats really gave birth to, first it would be Taylor's Tartar Terrier, and then ultimately Aegis weapon systems in terms of defense against the cruise missile and subsequently defense against the ballistic missile to protect our fleet.
Looking back, how revolutionary was Aegis at the time of its introduction compared to the Navy's previous weapon systems? Should we compare it to the development of ironclads or to nuclear power?
Yeah, I'm not sure I'd go towards development of ironclads. That's a good, it's a good genesis, if you will. But the revolutionary nature of Aegis was it 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 evolved what was standalone weapon systems into the entire ship as a combat system. And this was the genius of Wayne Meyer. I mean, it was how do we make the entire ship um, how do we uh, synchronize the entire ship so that that mission that the Aegis weapon system was going to need to perform, every aspect of ship's power, uh, uh, displacement, swap, speed, every aspect of the ship design, um, countermeasures, stealth would contribute towards the effectiveness of the Aegis weapon system in at first knocking down the cruise missile. So I think the revolutionary nature was the entire ship design was as a singular weapon system, and everything was integrated, everything contributed towards the accomplishment of the mission itself.
Admiral Wayne E. Meyer, the father of Aegis, he insisted on build a little, test a little, learn a lot. This podcast, in fact, is named as an homage to this mantra. How did this philosophy influence your own approach to managing the Aegis destroyer program?
Yeah, so let's let's put things in perspective. It's the Aegis destroyer program. The current class right now, I think we're looking at 117 total ships for the class, and I wouldn't write that in ink because the original DG-51 program was going to be 32 ships, 24 ships. It bounced around a little bit, but that incremental nature, that evolutionary nature of let's take this original design combat system and build into it upgradability. And then using that classic build a little, test a little, learn a lot, let's introduce further advancements in capability to not just keep pace with the threat, but to be the pacemaker against the threat. And so you look at the flight upgrades, you look at the baseline mods that have over the past 40 years since Arleigh Burke was put under contract, and you can add to that Tycho before. You look at those upgrades that have set the pace for naval warfare over the last 40 years. That's an outcropping of Wayne Meyer's build a little, test a little, learn a lot. The other important aspect of that approach is you didn't set yourself up for big failure. You didn't go, he was careful to describe that Aegis was never about the final solution, the ultimate solution. It was, let's understand the problem we're going after today. Let's solve that problem, and let's leave room for further advancements because the threat is always moving. And what that did was that gave the program a really solid footing in terms of getting into the budget and holding its place in the budget, giving his warfare sponsor, Vice Admiral Doyle, the ability to fight for and hold on to the Aegis budget. So it built success in the front end, and then incrementally retire the risk by developing and introducing incrementally, and then ultimately you go from a ship that at one point in time was designed for cruise missiles, and today we're knocking out ballistic missiles. It's a pretty phenomenal accomplishment, unlike anything else that we've seen in naval shipbuilding globally.
Can you share a moment from your time leading the Aegis program where Meyer's influence or spirit was particularly strong? Maybe in a breakthrough for a crisis?
Um, well, let me. Um, I'm going to first talk about. I'll go a little bit off script here. Um, I didn't meet Wayne Meyer until Arleigh Burke christening. But long before I met him, I knew about him. I had a naval instructor in grad school, a gentleman by the name of Corky Graham, Captain Clark Graham, who was the technical director for the Arleigh Burke program. And when he shifted over to teaching at grad school, his program, his course was all about Arleigh Burke and the design process, the design philosophy, and this was in the early to mid '80s. So I mean, Arleigh Burke had just gotten under contract, and as a project back then, um, he gave us a project of designing the next radar system for the Arleigh Burke. It was called the adjunct radar, and it was to deal with the next advanced threat. And it was a a grad school project, and it was not about designing the radar, but it was about designing the ship to be able to handle the radar. And so let's say this is mid '80s. I'm going to fast forward to 2008, 2009 timeframe. And I'm RDA, and what we're staring at is the need to upgrade the Aegis radar. So this is 20 years later, and what I'm realizing is I'm dealing with that same adjunct radar challenge from the mid to late 80s. Now, what had happened in between? The wall fell, the original Flight 3 destroyer, all the design studies were collapsed. We went to a Flight 2A, did not make those major upgrades to the program that were envisioned at the time. But now, 20 years later, we needed it. We had threats that required us to go far over the horizon in terms of detecting and also in terms of engaging. And so, in that point in time, it was like, well, what do we do here? Are we talking about a new ship class? Or are we talking about an upgrade to the Arleigh Burke? And it was that incremental approach, where let's identify what the threshold capability is required by the radar system to deal with that threat. And let's see if we have the ability to design for, develop, and build onto the 51 hull, recognizing that if we had to go to a new ship class, all the challenges that come with that. Put together a special team that, frankly, were all well Aegis trained, just superstars. From then, I guess it was PEOIWS from APL, also from Lincoln Labs and a few other organizations that really understood the threat and the technology. And long story short, what came out of this was the Advanced Missile Defense Radar (AMDR) and SPY-6. And without getting into the acquisition strategy, it was just that determination that this is the solution. This, it met all the requirements in terms of those technical requirements, those cornerstones that Wayne Meyer had pounded into us. And it was also going to be something that was both affordable and achievable in the time frame that was necessary. Got the sponsor fully supportive, and marched on down with the SPY-6 and now Flight 3, 20 years after it was originally envisioned. And about the same time, we had the introduction of the SM-6 missile. So it wasn't a simple matter of we need a radar that can look well beyond the current SPY-1 DV ranges. We also have to be able to intercept it. And it's that total combat system approach where the SM-6 is being developed that has the reach to knock out the target that the SPY-6 will be able to spawn. So the Flight 3, it's very early in the life of the Flight 3, but here we have a capability on the DDG-51 backbone that will take care of the threat as far forward as we can see it today. That's Wayne Meyer. That's classic Wayne Meyer, whom, frankly, as RDA, I had the great fortune of being able to. His office was over in Crystal City, to be able to make frequent calls on him. And in fact, if they weren't frequent enough, he let me know. To one, let him know what was going on in terms of what we were doing, but more importantly, equally, and more importantly, was get his insights into the options and whether or not he believed we were on the right path.
Aegis is still building and testing. In the context of today's evolving threats like hypersonic weapons and drone swarms, where is Aegis headed next?
Yeah, the hypersonics. The challenge with hypersonics, it's not a single. The solution to hypersonics is not going to be a single platform, 1v1. It's going to be a system of systems approach that's going to be necessary to deal with hypersonics. One of the things that Wayne Meyer was, he took everybody under his wing. And back in the early days of, I guess it was BIMDO at the time, Ballistic Missile Defense Office, and now it's Missile Defense Agency with a BMD office inside for Aegis. He would provide his counsel to the director of BIMDO, and how to break down the problem to boost mid-course and terminal, and how to go after that problem in each phase to increase the likelihood to ensure the intercept capability of the total system. So when you think about hypersonics, that detection phase is pretty critical. And the hypersonic weapon is not going to be, the detection is not going to be coming from an Aegis radar. I think we're looking at space-based assets. So let's talk about that system of systems. Aegis is core to that system of systems. And when you think about space-based assets, that interconnectivity with the Aegis weapons system gives it early detect, and then the ability to pick it up as it comes within the radar horizon, and then the arsenal of weapons that the Aegis weapons systems has at its hands to be able to intercept is a wicked hard problem. We have much work to do in that regard, but the progress that we've seen, before hypersonics, that takes back to CEC. CEC was a breakthrough at the time. How do you take multiple platforms and link them together so that one could shoot on the other's target, which then ultimately led to NIFCA and the Navy Integrated Fire Control Counter-Air capability. And I think it's that incremental, build a little, test a little, learn a lot, that incremental approach to dealing with these advancing threats that will lead us to, with the introduction of space-based assets, the ability to deal with hypersonic weapons.
CEC, meaning the cooperative engagement capability. Yeah. So with today's threat environment, China's advances, North Korea missile test, Iran's proxies, how has the role of Aegis changed from its original Cold War mission?
Yeah, so I think I probably covered this a little bit earlier, but day one, it was the cruise missile. Aegis. You think about Wayne Meyer's tenure as the program manager, 1970 to 1983. It was the heart of the Cold War, and the thing for surface warfare was to defend the carrier, protect the carrier, and the threat was the cruise missile. And so that ability to knock down the cruise missile, to give the carrier impunity for its role in terms of strike operations, et cetera, that changed. That changed with the proliferation of ballistic missiles, and the nation turned to Aegis to deal with the ballistic missile threat. I mentioned BIMDO and today MDA. The relationship Aegis has always had a seat at the table with MDA, and you see today Aegis warriors that have risen to be the director of MDA because of the success that the program has had. Well, that ability to detect, control, engage the ballistic missile, that's one thing in terms of protecting the fleet. But then we saw the challenges to Europe and frankly South Korea and Japan emerge with the proliferation of ballistic missiles. And so our allies turned to the US in terms of what solutions do we have? And I think it was very innovative. The European phased adaptive approach, commonly known as Aegis Ashore. It's Aegis destroyer. Today is called about a $2 billion platform. Well, before we went and positioned Aegis destroyers in the Eastern Med, let's put a permanent land-based Aegis Ashore system that can provide broad protection against the concern with the threat coming from Iran, and a much more affordable, permanent capability, strategically positioned. And then we followed quickly with phase two, which was the stationing of Aegis destroyers in the Med, and I think today we have 4 that provide a shield. Similarly, over in the Sea of Japan, you see Aegis destroyers similarly providing a shield. That's one aspect in terms of ballistic missiles. But then you look at the, frankly, incredible success that our ships have had in the Red Sea dealing with whether they're launched from Iran or from the Houthi rebels, dealing with the range of ballistic missile, cruise missile, UAV threats that have come. They've done an incredibly good job of dealing with a threat that, it's war in a time of peace. Protecting not just our allies, Israel in particular, but also the shipping in the Red Sea that's so critical to the global economy. In fact, just to foot stomp this a little bit. A year ago, just almost, April of 2024, Arleigh Burke was one of the platforms out there, first to fire the SM-3 going against a ballistic missile. So here we have a platform, I guess it was 33-year-old platform at the time, with the most advanced missile that we have dealing with the threat of the ballistic missile. That's an incredible testimony to the effectiveness of the Aegis weapons system, and equally to the effectiveness of Wayne Meyer's approach towards design, build a little, test a little, learn a lot.
How do you balance the need for innovation against the absolute reliability that's needed in a system to ensure the sailors' lives can depend on it?
Yeah. Well, a couple of things here. First off, I caution people when they start using the word innovation. Today, we have a tough challenge today with China. And more and more, the solution seems to be innovation. You hear that word everywhere you turn. We need greater innovation. I don't think there's ever been a lack of innovation, not just in terms of our country, but in terms of our naval warfare capabilities. I think it is core to our being, and I think Aegis is a great example of continuous innovation. I think we have other examples of innovation that have burnt us. LCS, extremely innovative. But the challenges on LCS are pretty famous. Zumwalt pegs the meter on innovation. Okay, but again, the challenges on Zumwalt have hurt us. Comes back to Wayne Meyer's philosophy. First, it's he gave a phenomenal talk at the I'll call it the commissioning of the Systems Engineering Institute out at Naval Postgraduate School. It's named in his honor, the Wayne E. Meyer Systems Engineering Institute. And his topic was, he called it profound simplicity. And I'm not going to go through it all here, but I recommend everybody go online, pull up his remarks, and make it a part of your playbook. But in his talk, he described, you got to understand what the problem is that you're working on. You have to really define the problem. And then don't go for that big bang solution that goes beyond the problem you're trying to solve. Solve that problem and then make sure everybody is working on it. And then you have to take this, what's often a seemingly unsolvable problem, large unsolvable problem. And you got to break it down into a large number of smaller solvable problems and then get your team working on it. And that real simplistic approach has ensured, I'll just call it the success of the program, going after the critical problems without trying to overreach and find yourself out of bounds in terms of technical risk. So it's managing the risk, solving the problem, and then your core question about how do you balance innovation and call it reliability. One thing he had a good way of pounding things home was you had this production program starting with Tycho, going through Arleigh-Burke, and you've got he referred to 3 fleets. He said, we got 3 fleets. We have the fleet in being, or the fleet at sea today. We have the fleet in construction, and we have the fleet in design. And our national security relies upon having 3 strong fleets. The fleet at sea today has got to be ready to fight today. The fleet under construction, it's got to be ready to win the fight tomorrow. And the fleet in design, the future fight. And so managing risk for him and for the Aegis program was all about introducing capability through that design and construction program before you landed onto the fleet. Elsewise, what you'll find is you'll be putting that technical risk on the back of the sailors who may or may not have trained for it, may or not be logistically supported for it, and it may or may not have the degree of rigor, technical rigor, that's required to ensure that in time of war, that you hit that button, that system, that missile leaves the rail and intercepts the target. Now, the challenge today is time. We can't wait 20 years, 10 years for these capabilities to be marched up through the fleet and design construction to get to the fleet at sea. And so there is a lot of collapsing that we've got to do in terms of those development timelines so we can introduce the capability more quickly, but then equally reliable. We cannot trade away reliability, else we're putting sailors' lives at risk. And I think we've made a lot of progress there. I think the key, if you think about that ship as a weapon system, you got 3 things going on. You've got the structure of the ship itself. And that's, Arleigh-Burke's 35 years. I think there'll be 40 years before we're done. Well, that structure has to be designed. And I'm not just talking about the stringers and deck plates. The platform has to be designed for that long service life. So it's not just at sea, but it's effective against the future threat. But then you also have the systems, the combat systems. And those combat systems get upgraded throughout the life of the platform. And what we are doing and need to frankly do better is introduce an upgrade cycle that is better at keeping pace with the threat with systems that don't need to be upgraded every couple of years. And that's a balancing act. But the third piece is software. Software, and here's where I think we are getting much better. I shouldn't say software, that's Wayne Meyer hated that term. Computer programs. The computer program, we need to be able to upgrade that almost on a daily basis, as called for by the threat. And we are getting there. PEOIWS has done a tremendous job using things like digital twins to test out software capability, the program's capability, get feedback from the fleet, real time, bring it to that digital twin, test out the solution, get back to the fleet through injecting an upgraded program. so that you don't have to wait for the next um, development cycle, et cetera, to meet the threat.
If Admiral Meyer were alive today and he saw the latest Aegis configurations, as you described earlier, Spy 6 radar, SM-6 missiles, integrated air and missile defense, what do you think would impress him the most?
I think what would impress him the most, and I'll use the Red Sea incidents. What will impress him the most was the crew's capability to deal real time with the threat. The systems, there's an unceasing march of technology, and that's going to happen. The threat is going to move on, and our weapon systems capabilities will move on. What I think he would have been most impressed by was that it was a pretty high density raid that they had to deal with in the Red Sea, and it was no notice. I mean, it was coming, and the watch team dealt with it. They could not have responded better than they did against that threat in the time frame that they were given. And it's a testimony to the systems were reliable, they worked, but the crew was trained and they had confidence in their systems, and they defeated the threat. That I think he would have. That would be what he'd been most proud of, because Aegis is not just a technology, it's not just a hardware system. It's the entire platform and the crew that fights it.
Indeed. Sir, we do not have the 600 ship Navy of the Reagan era, but we still operate throughout the globe, which is stressing the fleet. How can Aegis evolve to meet the demands across multiple theaters without becoming overextended?
Yeah, well, a couple of things. So in one of his missives to me, and I totally agree, was when we think about the design of our ships, and we had this thing called now it's called the Long Range Shipbuilding Report. It used to be called the 30-year Shipbuilding Report. And people ask, why do you publish a 30-year shipbuilding report? Recognizing that the answer is because that's how long it takes to build a fleet. That's how long it takes to build a navy. It's a 30-year process. And if you want to influence long term, you've got to think now and start to lay in accordingly. And for Wayne Meyer, what that meant was the ships that you design and build, if you design them for today's threat, they're going to be obsolete 5, 10 years from now. So you have to have a platform that is multi-mission and that can adapt to an ever-changing threat, ever-changing environment. And so that was critical for the DG-51 design. And you look at it, yes, it's an air warfare, deals with the air threat, but it's got ASW capability, it does have surface capability. It's a multi-mission platform that whatever the environment, whatever the threat, it's going to be a part of the solution. And particularly when you consider that, we have at any one time we might have 2 to 4 carriers deployed. Well, there are a lot of threats and operational scenarios where that carrier is not going to be around, and you're going to rely on surface combatants to meet the mission, whatever it happens to be. So multi-mission capable is probably the most significant aspect in terms of your question there, dealing with that wide range of threats and the global demands. The other aspect, frankly, is forward deploying. And so you see, I talked earlier about the destroyers in the Med. We've always had forward deployed presence in Japan. What we learned, sadly, tragically, through McCain and Fitzgerald, is that we've got to take good care of our forward deployed assets. That's in terms of material condition, but also it's in terms of training and readiness of the crews themselves. So I think we'll see forward deployment continuing to be a critical aspect of our operational, our strategy. And I think that multi-mission capability of the Arleigh Burke makes it the ideal asset for forward deploying. And that crew training, readiness, and material condition needs to be front and center in terms of our planning and budgeting in terms of taking care of ships and crews.
Mr. Secretary, if you were advising young engineers and officers just entering the Aegis world, what's one piece of Wayne Meyer's wisdom that you would want them to live by?
Boy, that's a tough one. I'd point out a couple of things. He was uncompromising when it came to delivering. That simple, what's the problem? Well, the nature of the beast for the United States Navy is when you answer that question, that problem has to be solved. It's not discretionary, it's not optional. So defining that problem, it is going to be absolutely critical that we get to that solution. And what that brings with it is dogged determination, unceasing effort, whatever it takes to solve the problem. Closely associated with that is urgency. You have to bring an urgency to the job every day because so much relies upon solving that problem. So to find the problem, bring a sense of urgency, and then, classic Meyerism was, you're not going to solve it alone. I tell people, I steal from his book all the time. I said, hey, build a big team, because the nature of the problems that we have to solve, they require a big team. And it's everything from your systems engineers. You have to close tie to your resource sponsor, the fleet, so you understand how the sailor is going to be able to operate the system or solutions that you come up with. Government, industry have to be closely partnered. And so you have to understand the problem, bring a sense of urgency, and build a big team. Everybody pulling in the same direction, understanding what their role is in terms of solving the problem.
Mr. Secretary, how would you describe Admiral Meyer's legacy?
Yeah, Steve, that's a great question, and there's not a simple answer. I'd say I would say his legacy is threefold. Okay, and first and foremost, and most obviously, and what we've been talking about is the fleet of Aegis ships. There's 27 cruisers. I mentioned earlier, I think right now the ship plan has us getting to 117 destroyers, international Aegis ashore. There's a fleet of Aegis ships that if you take the 117th destroyer and then you just plot out its service life, that ship will be getting decommissioned in the 2070s, which, that's a century after Wayne Meyer stood up the Advanced Surface Missile System program, a century. So right there's an incredible impact in terms of the United States Navy, our capabilities, our allies' capabilities, and the security that they provide around the world. So it's the fleet of Aegis ships. Second is I'd call it the Meyer method. It's his model, the model that he created and left behind as it relates to excellence in systems engineering, program management, ironclad alignment between the program office and the warfare sponsor, and then the partnerships with industry that he formulated during his time and have carried on since. So the Meyer method, the model, I think that's another glowing legacy that he leaves behind. Third is I'll call it his sons and daughters. Wayne Meyer built a team, and he did not profess to do things alone. He built a team of professionals And I had the benefit. I was second or third generation. And I had the benefit of learning from that first team that he put out there on the field. It was the Randy Fortunes. If people remember Randy, the role that he played in terms of Aegis shipbuilding, and his counterpart Larry Rogers over in the combat systems side. And characters like Fred Parker, who was both a program manager and an aide to Wayne Meyer in his last tour as CO6, and Tom Pugh, who had a lot to do with getting Arleigh Burke built from his seat over in Once Upon a Time in 400B, and on and on. But just there's a professional team that he put on the field, and that team recognized the importance and what was special about Aegis, and they made it their mission to train the generation that came behind them. And frankly, that's the great challenge. The ships will last. The Meyer, the model, the method, et cetera, that will be propagated. I mean, people, they know what good looks like, but it's that team of professionals that requires a hand down from generation to generation to continue to put on the field the professionals that our Navy needs to ensure that that standard of excellence that Wayne Meyer brought to us all continues to lead the fleet. So I'd say legacy, the ships, clearly the ships and ship weapon systems, the method and model, but also that team of professionals. And it's in the hundreds now of individuals that have learned directly from him or from the lessons that were handed down generation to generation.
Sir, I often ask this question on the podcast of the guests. Do you have a favorite naval engineering sea story?
Well, this is on. I'll go to my time as a program manager. Well, actually, I got a couple of them.
We can listen to 2 or 3, sir, and it can inspire the next generation of engineers.
Well, and these are real simple, but so Arleigh Burke, on the Burke was under incredible schedule pressure, and not because the Soviet Union, but because of Congressman Dingell. This is a little bit of history that's buried, but so Bath Iron Works, located in Maine, Bath, Maine, got the contract for the Arleigh Burke, and that was the future for the shipyard. They had a couple cruisers, seven. They had 7 cruisers they were going to build. They had finished out the frigate program, but the future for Bath Iron Works was the Arleigh Burke program. And so they were all in. It was that team that Meyer helped to build between government, Navy, and industry, and then the other members of industry, Ingalls, Lockheed Martin, or Marietta at the time, all part of that team, and everybody pulling in the same direction. But the Senate Majority Leader at that time was George Mitchell. And George Mitchell, he basically pushed through Congress the Clean Air Act. Seems like a good thing. Well, what the Clean Air Act looked like to the state of Michigan was an attack on the auto industry. John Dingell, representing Michigan and Detroit in particular, he basically took that as a shot across his bow. So he decided he's going to take a shot at the Arleigh Burke program. Biggest, Bath Iron Works' biggest employer in the state of Maine. So Dingell decided he was going to attack the Arleigh Burke program in response to the Clean Air Act. And what he did was he put the program under a microscope. He just bashed it publicly. He attacked it on the Hill, hearings, wherever, every chance he had to take a shot at it, just looking for a weak spot so he could bring it down. And that made schedule critical, because every milestone, if you missed a milestone, that would become the reason why the program needed to be slowed down and put jobs at risk in Maine. So that's the background. What that meant, we were coming up to a christening, September 16th, 1989. I mean, I don't remember that date. We were going to make that date no matter what. no matter what. Well, you know, the nature of a first-class ship, at least up to now, for the last couple hundred years, is concurrent design and construction. You have design process, detailed design process going on while the ship is being built. You have to make sure that design is staying ahead of the construction. But quite often you have holdups, and you know, we had some holdups on the early Burke. Piping drawings were behind, electrical drawings were behind, so everything was pressurized. Well, we had to do a redesign of the mast, and what that meant was that the mast was not going to be ready for the ship's launch. And I was a production officer, and I went to the shipyard and I said, "Look, you're going to work around the clock. That mast is going to be on that ship when it launches." Well, the reality was they weren't going to be able to finish it sufficiently. By God, we were going to erect the mast. So we erect the mast on the Arleigh Burke. She was launched on the ways. Beautiful thing. All the photographs, there it is. The ship launches September 16th, pulls up pierside. That's a Saturday. Two days later, September 18th, cameras are gone. We're taking down the mast and returning the mast, because the mast on the Burke is huge. It's monolithic. And returning it to the outfitting buildings to finish the outfitting in a more orderly, controlled process, etc. And then ultimately should be finally installed months later. It's a case of, you know, you would not propose to do that for sake of efficiency, but it's about keeping the program alive. And few people, you know, I'm revealing this to the public after 40 years, but few people knew. But that's what we had to do in order to keep the program moving forward. That's one. Another Arleigh Burke story, which is very small by comparison, was you know, you walk the spaces every day while it's under construction, and we had on average 1,200 people a day on that ship working on it, which today a Burke under construction might have 300 people on it. So the density of labor on that ship to try to hold schedule, it was impressive, to say the least, and a lot of work going on concurrently in the spaces. And I just remember walking into the Combat Systems Equipment Room #1 up forward in the ship, bows of the ship, where you have a lot of electronic cabinets, and you also had some power distribution that went through there. And so you had this 400 amp cable, TSGU 400. I mean, you hold on to these things. Well, 400 amp cable has a bending radius that you know, it's not equivalent to the circumference of the Earth, but it has a pretty wide bend radius. And the cabinets are on their foundations. It's a tight compartment, and you've got mechanics with come-alongs, and they're trying to get this cable to bend so that they can connectorize it and plug it into the back of this cabinet. And I remember talking to the mechanic down there, who is probably a great American, probably 300 pounds, all muscle. And I'm asking him, "How's it going?" And he says, "Some engineer in some building somewhere with a pencil drew a line that imagines that I can bend this cable to match up to this cabinet." And you know, you got to sit there and think about that, right? I mean, there's thousands of engineers working on the program. They're all doing their best and dealing in the time with, it wasn't CAD, it was 2D drawings. And with their pencil, just drawing things that needed to happen without fully understanding what it was going to take to make it happen, much less when the ship is being built out of sequence. And it stuck with me. And the rest of my career, you know, talking to engineers, it's like, hey, you got to begin with the end in mind. It's not about just pushing your drawing out. It's like they got to build this thing, whatever it is, and you got to keep that begin with the end in mind there. Yeah. A last one that I'll share. So that was as a production officer, maybe, gosh, 15 years later or something. I'm a program manager for the San Antonio class, which had a lot of that innovation that I talked about earlier. San Antonio was a tough ship to build. Um, but similar challenge, frankly, to the early Burke in terms of parallel design construction with the lead ship, some schedule pressure, more importantly, cost pressures. Got to get it done. Critical mission. We're going to succeed on this thing, but required a lot of detail that has to be muscled through. And we do. We get through all that, and we get to sea trials. Now, there are certain things on sea trials. It's nature of the beast that you don't get a chance to test the system until you're out there. And we had some hiccups. I mean, we got underway on the first sea trial. We hadn't left it was down at Ingalls. We were in Avondale, and we hadn't left the gotten out of the waterway yet, and we dropped the load right away. And let me retrace that. It was Ingalls, because we moved the ship from Avondale to Ingalls for trials, and we were out in the waterway of Ingalls, and trying to get out into the Gulf. We went complete cold and dark. Alarms going off left and right, everything else, and I was in central control at the time with InServ, and everybody's running around, and InServ looks at me, and I said, "Just be calm. They got it. They got it." We had engineers and test engineers, and we had such a professional team there that knew the details that I had no concern that they weren't going to get the power back up, restore the load, and get us safely back out to sea trials. And they did. They did. I mean, later on, we found out that the issue was computer program, having to deal with all the ships loaded on it for the first time, and it crashed. We had to redesign the computer program. And then later on, we're out there on trials, and amphib ship, we're going to go ahead and submerge for the first time for floating the well deck. And I remember standing next to the ship design manager in the well deck up on the wing walls, and I think we took her down to we were down to like 8 feet. And I simply turned to him and said, "We're going to be able to get back up, right?" And he said, "Don't worry about it. We got this one." And we did. But it's just one of these deals where you got on trials, let's build a little, test a little, learn a lot. We learned a lot on that sea trial. And what I learned was that I had such a professional team, just a team of pros that, it wasn't an Aegis ship, but they followed the Wayne Meyer model of just determinedly, plotting away on all the details to ensure the success of the ship. And that was 2005. Here we are 20 years later, and we're still building San Antonios. Here we are 40 years later, still building Harley Burke destroyers. You got to master the details. You understand the problem you're trying to solve. You have to build a large team, professionals. You have to all pull in the same direction. And you have to be determined and just drive till you get the job done.
Mr. Secretary, is there anything else that you would like to share with the ASNI audience?
I touched on that term innovation, and there's a lot of noise in the system right now. That, hey, we need greater innovation, and people are looking to they're looking to foreign shipyards for solutions, looking to Silicon Valley for solutions. They're looking far and wide for solutions. And I go back to my earlier comment that we've got innovation. Now we do need more, and we do need the ability to not become a slave to organizations, a slave to process, keep our eye on that problem that we're trying to solve, and work as one team in one fight. I think we have work to do that. Government, industry, the problem is bigger than either one of us, frankly. We need to find better ways to work together, solve the problem. And this is going outside of Aegis. A good friend of mine, Mike Petters, once the president of Newport News, then the CEO of HII. Now, Mike is an absolute professional. He defines government industry partnership, and he's had to work on the toughest problems. There's nothing, if you haven't seen a carrier under construction, there's nothing that compares. And to be able to do that side by side while you're working on submarines and overhauling and decommissioning nuclear carriers, it's an incredibly complex shipyard and processes that he has going on down there. Anyway, Mike in 2006 wrote an article. I'm going to guess it was Proceedings, but I'd have to go back and find it. But I read the article back in that time frame. I think I was on the Hill at the time, and I was like, he nailed it. He nailed it in terms of the challenges that are systemic to shipbuilding and what it takes to solve them. And a couple of the keys are one, stability. We need stability in terms of our shipbuilding programs. And frankly, I made that. That was 2006. I took over as RDA in 2008, and you'd be hard pressed to find me giving remarks where I didn't talk about the critical need to have a stable plan for shipbuilding, because shipbuilders have to plan, they have to hire, they have to invest, and in order for them to succeed, they need to understand what the future holds. So stability. Second is skilled engineers and labor. And if you look at the challenge that we have today, the greatest challenge that we have today, it's a shortage of skilled engineers and skilled labor in our shipyards. And so while people are looking for greater innovation to solve our problems, sure, we do continually need innovation. What we need most right now is that skilled labor, engineers and mechanics that we rely upon to build our ships. And then the third, I think, key point that he made was government industry relationships. We each have to understand the other's problem, the other's challenge, and we have to go after that win-win solution, because there is not a scenario where one wins and the other loses. We either both win or we both lose. And in order for the win-win, we have to understand each other's challenges and work collectively to solving both sides of the equation. So my hat's off to Mike for what was a really tremendous article back in 2006, which I think rings more true today than when he wrote it back then.
Well, thank you, Mr. Secretary, for taking time to discuss Admiral Wayne E. Meyer, the story of Aegis, and to share with us your wisdom and experience. I hope that we can welcome you back in the future to Talk a Little, Learn a Lot, the podcast of the American Society of Naval Engineers.
Thanks, Steve. It was my pleasure, and I always welcome the opportunity to talk shop.